Asynchronous, synchronous RAM. What is memory? Memory is the space where the computer which stores the data right now. Two types of memory: static RAM and dynamic RAM. Where static RAM is super fast and it holds the data by using flip flop and it is expensive. Coming to dynamic RAM, which is slow working and it holds the data, much more data. Next, goal of these types of the memories is like to understand what we include in the dynamic RAM to make computer easy. Next, static RAM is coming.
Static RAM stores the data in the using the flip-flop circuits. That means the data is stored as long as the power is on. It is very fast and reliable. Due to this, it is no need to be refreshing. It is very expensive and takes more physical space, and it is used in the CPU as cache memory. Dynamic RAM which stores the data into the tiny capacitors which loses the charge constantly. So it needs to be refreshed constantly to store the data intact, and it works slower than the static RAM. It is cheap and can hold huge amount of data. It is used to store as main memory in computer. Next.
So in DRAM there will be two types of DRAM, that is asynchronous and synchronous. In the old way, like in the older computers, we will be using the asynchronous DRAM, where there will be no clock system. The timing issue was there. Like if the CPU adds the data from the memory, the sending of the memory would be at any time. Until then the CPU has to wait. Like it has to wait idle without going to any process. It has to wait until the memory responds. Those time was wasting, and until the memory responds, it doesn't switch over to any other process. It keeps the CPU idle. The CPU wastes the time doing all these things. For this reason, if more pressure was more process has to be executed by the processor, it has more pressure on it, and it will be stuck at any time. Like more pressure will be occurs number of instructions, like billions of instructions to be executed by the processor. It has wasted its time while waiting for the data to come from the memory. So it causes a wasting of time. For that reason, in the modern system we will be using the synchronous DRAM, where the CPU requests the data from the memory instantly, at which time the data will be sent will be known by the CPU. Like if it asks data from the RAM, then it will be knowing at what time the data will be sent by the RAM, and it will go to the another process and continue its execution. If in that case, the faster performance will be there. Like any number of executions, like instructions will be processed by the CPU. There will be no idle time for the processor. It will be continuously executing the instructions that are given by the OS. So it is ideal for the modern system. The comparison table, like what are the features of SRAM, asynchronous DRAM and synchronous DRAM. In the case of speed, SRAM is very fast. Like it will be instantly send the data when the processor adds the data to the memory, and refresh needed. For SRAM, refresh is not needed because in the SRAM we will be using the flip-flops. Like the data will be retained in the memory as long as the power is supplied to that SRAM. So there is no need of refreshing of the data, and the clock is not needed because there will be no synchronization between the memory and the CPU. So clock is not needed in the case of SRAM, and it will be send the data instantly. So there will be no synchronization needed in the static memory. And for it is best for cache memory because the data sending will be very fast and it is a volatile memory. when the power is off, then there is no retainment of that memory. For that reason, it will be best for the cache memory. So in cache memory, we will be using the SRAM. And in case of asynchronous DRAM, the speed is low because there is no synchronization between the memory and the CPU. For that reason, the speed of the data sending by the memory to the CPU will be very less. And a refreshment is needed in the case of DRAM itself, because in the DRAM we will be using the capacitors to store the data. The capacitor stores the data in the form of charges. The frequent discharging of the data will be happening. So there is a case of losing of the data. For that reason, refreshment is needed, and frequently we need to recharge the capacitors. And uses of clocks, as in the case of asynchronous, the name itself suggests that it is not synchronized. So clock system is not needed in that case. And it is best for old computers where simple architecture were used. Means there is no complex architecture. In the case of asynchronous DRAM, it will be used the simple architecture. So asynchronous DRAM was best suited for the old computers. In the case of synchronous DRAM, the speed will be better than the asynchronous DRAM, and also refreshment is needed because it is a DRAM. The capacitors are used, and clock is needed because it is a synchronous. The synchronization between the processor and the memory is needed, and clock is needed because there is a synchronization. It is best for the modern main memory. Main memory will retain the data as long as the recharging is happening. Like cache memory is removing all the data when the power is off. But in the case of main memory, it will retain some of the memory. Some memory will be gone, but most of the memory will be retained even the power is off, because it is using the capacitor. As long as the charge is remained on the capacitor, the data will be remained. So next will be continued by static RAM is used very fast, and it is used in cache memory. Dynamic RAM is large in size and storage. It is used in main memory, and it shift from asynchronous to synchronous greatly without synchronized. Applications and games will run much slower.